This is our Unit 5 project on linear versus exponential calculations. This project was made by Ava Runyan and Hunter Johnson. An M&M's factory produces 12 M&Ms every minute. You should complete the table below, and when you finish, your table should look like this. Now, the now-next equation for this problem should look like this. Next equals now plus 12, because as you can see in the table, it is increasing by 12. And your explicit rule should be y equals 12x, and there is no y-intercept, as you can see. After you finish, you should graph that equation, and your graph should look like this. It is a straight line because it is linear, and it increases by 12 every minute. So, for our prediction problems, our first problem is after how many minutes will there be 108 M&Ms, and that will take 9 minutes. You just have to use your equation to figure that out. And how many M&Ms will there be after an hour, and that is 720 M&Ms. This is our exponential growth problem. A town's population is 5,000. It increases by 20% every year. You should complete the table below, and after you complete the table, it should look like this. As you can see, it increases by 20% every year. So now you need to write a now-next equation. Your now-next equation should be next equals now times 1.20, and the reason it is 1.20 is because you are increasing by 20% every year. Your explicit rule should look like this: y equals 5,000 times 1.20 to the x power, and 5,000 is our y-intercept. So what will the population be in 50 years? In 50 years, the population is going to be 45,502,191 people, and you just need to plug this into your equation to figure out your answer. You also need to plug these numbers into your equation to figure out what the population, or to figure out when the population will exceed 1 million, and that will be in 30 years. After you complete all this, you should graph these equations, and your graph should look like this. As you can see, it curves, which means it is exponential.
For this linear decay example, Jackson has 600 papers. After 2 hours, he sold 14 papers, and after 3 hours, he sold 21 papers. Well, after each hour, he sells 7 papers. So the graph would look like this. First, you have 600, then 593, then 586, and so on. And it's straight because it's linear, and you don't want to put a line on it because you can't have part of a paper. Then we have the table over here. Just basically writing out the entire graph at 0 hours. He has 600 papers because he hasn't sold any. 1 hour he sold 7, so he has 593, and so on. Okay. The start value for this equation is 600 papers because that's how much he starts with. And the now next rule is next equals now minus 7 because each hour he sells 7 papers. And the linear equation is negative 7h plus 600, because 600 is the y-intercept, or where we start, and since he loses 7 papers an hour, that would be negative 7h. Okay, so just a quick prediction. In 10 hours, Jackson will have 530 papers, because 10 times 7 equals 70, minus 600 minus 70 equals 530. Okay, for exponential decay, we'll be using the problem. A new TV costs $900. For each year the TV is owned by a buyer, it loses value at a rate of 15% of the present cost. Okay, so during the first year, it would still be worth $900 as represented by our graph, because it hasn't been owned for any length of time yet. So, our graph axes are represented. C represents the y-axis for cost of the TV, and y represents the x-axis for years owned. So at 0 years it would be 900. At 1 year it'll be a little bit below $800, and so on. So quick prediction using that: in Oops. In 9 years, the TV will be worth $208.46. Just using that continuous exponential equation. So then we have over here, probably should have done this first, but the start is 900 because that's the initial value of the TV. And the now next equation is next equals now times 0.85 because we're losing 15% each year, or multiplying it by 0.85. And then the exponential equation would be p equals 900 times 0.85 to the y power, because 0.85, as I said, is our decrease rate. No, 15 is, but 100 minus 15 equals 85. So then we have our table over here. At 0 years, the TV would be worth 900 since that's our initial value. Then it would go down to $765 because that's 85% of 900. Then 85% of 765 would be $650.25, and so on. So that is how you work out this problem, and hope you enjoyed.